I know that so many of you really do not like the application problems, but this is where we see why we need to learn what we're learning. So let's take a look at an application problem for a polynomial inequality. For our example, I want to look at the position function of a free-falling object near the Earth's surface. The problem will be stated like this. An object that is falling or vertically projected into the air and has its height above the ground, S of t, in feet, given by S of t equals negative 16t squared plus v sub 0t plus s sub 0, where v sub 0 happens to be the object's initial velocity measured in feet per second. T is the time in seconds that the object is in motion, and S sub 0 is the object's initial height in feet. Now let's use that function in an example. An object is propelled straight up from the ground with an initial velocity of 80 feet per second. Its height in time is then modeled by S of t equals negative 16t squared plus 80t, where the height S of t is measured in feet and time t is measured in seconds. In which interval will the object be more than 64 feet above the ground? Given the function f S of t equals negative 16t squared plus 80t, where S of t is the height, my question asks, where is the interval of time, that's t, when the object will be greater than 64 feet above the ground? So this is the inequality that they are asking me to solve. So I'm going to say, first of all, there's no denominator, so I don't have a critical number coming from the rational part. So I'm going to set it equal and pretend it's an equation that I'm trying to solve here. And how would I solve this quadratic? Well, the first thing I would do is set it equal to 0. Well, minus 64 equals 0. And the next thing I'm thinking as I'm rewriting it, that I think I've got a common factor that I can take out. I want to take out, I believe I can take out an entire negative 16. That sure would be nice because it would leave me with 1t squared. Okay, the negative is going to change the plus 80t to minus, and 16 times 5 is 80, so that's going to leave 5t. And taking out the negative is going to change minus to plus, and 16 times 4 is 64. Worked out beautifully and nicely. So I'm going to say I've got two guys multiplied together to give me 0. I can promise you the negative 16 is not the 0. So technically, I guess you could say I'm dividing both sides by 0 rather than just totally ignoring it. But then I'm going to factor, this is t minus 4 and t minus 1 will give me t squared minus 5t plus 4. So now I've got two numbers multiplied together to give me 0. So one of those two numbers has got to be 0. So either t is 4, making the first parenthesis 0, or t is 1, making the second parenthesis 0. So I have a number line, okay? And here's times 0 when we fired whatever it was we fired into the air. Here's the number 1. Here's the number 4. Now, reasoning can kind of tell you which part of this number line has to be the solution set, because he's fired from the ground, so this can't be it. And 4 seconds, well, that's where he is, coming back down again. So I'm guessing past that is going to be closer to the ground, and this is going to be true. But I want to double check. So I'm going to pick a number that's in here somewhere. I'm going to pick on, let's say 2. It's a little too close for 2, but that's okay. And I'm going to test it. Negative 16 times 2 squared plus 80 times 2. I hope that's greater than 64. My reasoning's all messed up. Okay, so negative 16 times 4 plus 160 is greater than 64. That's negative 64 plus 160 is greater than 64. 160 minus 64 is going to be 96, and that is in fact greater than 64. So this interval from 1 to 4 is where it will be above 64 feet. If they had said at least 64 feet, I would need brackets instead of parentheses. But for simply more than 64 feet above the ground, from time 1 second to time 4 seconds will be my answer.